Yo,
Hello, who's that? Alexis?
I think it was Gabe. Well,
Okay. Okay.
yeah.
Hey, Gabe. Okay. Get your screen set up and ready so we can start on today's assignment. You're going to be logged into Edsby and logged into Gmail. Get this attendance ready. Hello, Lisa.
Hi.
So use this time to start setting up your screens, everybody. Okay, Alexis, Lisa, and Gabe. Let's do a side-by-side analysis. Okay. Hello, Miss Richardson.
My bad. That was rude. Good morning.
All right. Everybody besides Lisa, because she's a bulldog, has to have their camera on the entire time in class. So get ready to get that turned on. Thank you, everybody. Hey, Daje.
Hey, Mr. Tyler.
Okay, so in 2 more minutes, we're going to get started on norms and then begin today's assignment. You want to start by, if you don't have the slide deck, you want to open that up and you're going to get to a simulation that you need for today's assignments. It's in the chat over here for you guys. And that's how you're going to get to the simulation. It's going to be in the physics classroom, the simulation you need. So I'm going to do it step by step. It's click on me, we come to the prep period. And if you click on the physics classroom, you'll have access to this simulation here. I want you to click on that in advance. Once you click on it, give it a second. Oh, I went to the wrong slide. So you want to have this simulation running, okay? You can find it in the classroom under the physics classroom. How much time we got left before I mark people absent? Oh, a minute. Let's see how many people are here. Okay, got that. Okay. Okay. All right, so let's get ready. You should have your screens resized and logged into Edsby, by the way. And you're gonna want to open up a new tab. In one window, you're gonna have Google Docs, so make sure you log into your Gmail. And another one, you have Edsby going. We are in period 3. Be sure to open up in Google Apps, a Google Doc, and start a blank document. Okay, so goes the roll call. They are not present, the rest of the students. I don't see Kathy. I don't see Champagne, Connor, Davis. Miss Franklin's not here. Lightsy's not here. Joel Moreno's absent. Lamar Porter absent. Christian Fuentes absent. I got Richardson. She's present. Millie Terry absent. Jamil Tyler absent. Alexis Valdez is here. Mr. Wallace is absent. I have everybody else. Lee Carter's not here. I think I didn't say his name. Okay. Okay, so that saves it to this office. They can talk to the rest of the students. So let's get the norms out of our way. We're gonna go down the list and do them one at a time. So Google Meets goes in alphabetical order of your first name. The first person on the list would be Miss Richardson. Can you read number 1?
Sure. No one has another person.
Thank you. Alexis, number 2.
Education and the classroom are sacred.
Thank you. Dajay, number 3. Ms. Moore, are you there? Okay. Gabriel, can you read number 3?
We will never be having a web together ourselves, our school, our family.
Thank you. Lisa, number 4.
Excel Academy and software. Student is always a lady or gentleman.
Dajay, can you read number 5? All right, she's not there. So I'll read number 5. We take pride in Excel Academy and Southwest. Number 1, Ms. Richardson, can you read from the academic norms?
We respect the opinions of others.
Thank you. Alexis, number 2.
We respect the culture of the classroom.
Thank you. Dajay, are you there? Okay, she stepped away. Gabriel, number 3.
We are attentive and participant.
Thank you, sir. Lisa, number 4.
We have high expectations of ourselves, our peers, and our teachers.
Awesome. Okay. So the last one I'm going to read is we are here to focus on preparing ourselves or preparing you guys for gaining post-secondary endeavors, right? And who knows what those post-secondary endeavors are? It's 3 of them for 5 points each. You can get 15 points. Who can tell me? Alexis told me 1. That's 5 for him. What's another? It's 2 more. Welcome to class, Mr. Carter. Oh, okay. Gabe said all of them. All right. Cool. I see you there. Okay. So if you don't know, it's trade, military, or college. These are your pathways after high school. Let me mark Carter present. All right. So with that said, we have an assignment today, right? We're going to do the simulation towards the end, or maybe we should do it towards the beginning. I'm not sure. But let's get the simulation started. So I showed you how to get there in the Google Classroom and put the link in the chat. You might want to get that going because depending upon your internet speed, it might take a little time to get going or not. All right, so you should have that. Click on that link and it should give you access to the simulation. Now, real quickly, when we do this problem, we're going to create a simple circuit. We're going to take a snapshot of it and we're going to import it into our Google Doc. So I think for this portion of the intro or lab, I think its intro should work fine. So if I'm in a laboratory setting, what does it do? It gives you a few more options. Yeah, it gives you 4 more. So click on lab because I want you to have all the options. And we're going to create what is called, I want to say, a series circuit. All right. And if you look at our title of today, you understand what that's all about. So we're going to create this type of circuit, right? We need a battery. So grab a battery. I think everybody can see what I'm doing, right? Let me see here. Yeah, they can see what I'm doing. Next thing you do is you're going to try to put set the circuit up the same way I have. So I'm taking some wire and I'm making a series circuit. Now, a series circuit is where you have resistance or loads that are in series. So resistor, right? and then wire. And we use one more resistor. Just want to connect this up as a series or a loop. If anybody's ever watched NASCAR, you know that this is exactly what a loop is. They go in a loop and then they come back to the beginning. It makes a lap. Okay, so almost through, and you should be connecting this up the way I'm doing it so you can actually utilize it. So, all right, so you just want to snap them together like they're junction points. And I hope you're doing it with me because in a minute we're going to have share outs. So we'll put a bulb right here.
Mine's still loading.
Yours is still loading? Okay.
Yeah.
It's probably the internet speed, Lisa, so just be patient. So as you can see, everybody, the bulb is now lit. Okay. Now, this is the same thing you're going to need to do. Zoom in a little bit. Or is that zoom back in, I guess? Not zoom back in. So now, the only things you need to make sure you have selected for your snapshot is the values, which tell you that this is 9 volts here, 10 ohms here, 10 ohms here, and even the light bulb serves as 10 ohms. Okay. So we got that part done. There's also a way to change the resistance on each of these. Okay. Now we're going to be using this in a moment for our problem. I'm going to remove the light bulb for a moment because I want to get a third resistor in there so you understand exactly what's about to happen. So grab this resistor and it'll connect it. All right, so try to get this set up. I know some people is still loading, but here are the settings that you need for your simulation. So if I come out of this, I'm gonna be setting up my document. And you're going to be setting it up as the 1S problem because I think it's like 3 resistors in there, right? But the third resistor we don't know. So we're going to calculate that. All right, so let's begin. You know you need to name your document, do now. And today's date is the 21st of October 2020, right? Next, we got to put our header in there. So it's going to be my name, or your name, I should say. Let's put my name there. I'm just typing it out as I talk to you guys about it. And of course, the same thing, date, October 2020, period is what? Well, we're in not the last period, we're in the third period of the day. So we're at the middle ground, right? Before we all get out of here. 2 more periods to go after this. So you guys are intro to engineering with robotics students. Okay. Title. Who knows what the title is for today? Oh, Alexis threw it in there real quick with it. Yep, that's exactly right, sir. 10 points. So if everybody sees in the chat, Mr. Valdez helped us out. I'll grab this from the chat and I'll put it in my Google document. You should put it in document the same way I'm doing it. Okay. You guys should still be trying to get that simulation going too. Let me zoom in and make this a little bigger so you can see it. So the title goes right in the middle of the page. Okay. Now we need our exit slip, and this is where that term in the brackets comes into play. So exit slip is worth 25 points, right? It's always a deal. And our classroom term of the day is what? Well, it's in the brackets here that Mr. Valdez provided for us. It's also, he got this from Edsby, so it's nothing special there. He just knew where to go. I see in the chat, Alexis is helping out with the problem. Thank you. It's another 10 points. Lisa helped us out with how to set up our exit slip. That's 10 points for her. So it's real easy if you guys are participating to survive this class. So what did she say was the first one? She helped me out with it. She said, the term is, she did it in reverse. So the term is series circuit. She's right. And the word of the day, she told us, this is how you guys got to type it up. But don't think you're done. You still got to put the definitions of these things in here. And Lisa helped you out with one of the definitions. The word of the day is what? Well, we said, if you look at the chat, it's empathetic, right? Yeah, empathetic. So it's like EM, what is it? PATHIC. And you need the definitions of both these words out, okay? That'll get you 25 points extra on a previous assignment because it's an exit slip. So don't forget to do those definitions. It's real easy. You can look on Google or you can take Lisa's definition and put it in there. Next thing is, of course, the questions. You have 2 questions. Mr. Valdez gave us one of them. So I'm going to put this here because that's our next thing we need. This is the question we're handling. All right. So that is the first question that is in EDSB already. All right. So let's blow that up some. And this is where I was saying we have to set it up the same way for our problem. So our problem states that your resistor R1, let's see if it goes there. This is what I was testing out, but it might not. There might be a limit. Can we take the voltage to 24.6 volts? That's in the problem. So if I grab this simulator and I look at it, if I click on the battery, I can change the voltage. So can it go to 26? It sure can. It goes to 50. So we want as close as we can to what the problem said it was. It was 26 point. I'm getting close. You gotta be careful because it's jumpy. I'm gonna say 26 volts, okay? You need to set yours to 26 volts. Let's go back to the problem again. So I'm looking at the problem, but now I'm gonna have, let me see, Miss Richardson, can you read the 1S problem that Alexis gave us at 12:23?
Mr. Tyler.
Oh, God, hey, you back.
For real?
I've been here the whole time.
I've been calling your name for a long time.
No, you haven't.
Yeah, okay.
I haven't heard nothing. Like,
I don't know.
I haven't heard nothing. I was just gonna say, like, do we say the norms or something? Like,
Yeah, we did there. But Miss Richardson, go ahead and read. I'm glad you're back, Dajay.
A circuit consists of 3 resistors in series to a 24.6 volts of battery. The current in the circuit is 0.0327 amps, given that R1 equals to 255.2 ohms and R2 equals 157.8 ohms. Find A, the resistance of R3, and B, the potential difference across each resistor.
Resistor. Thank you, Miss Richardson. All right. So that's where I'm getting. That's why I'm telling you, look at the problem to set it up. It's actually, we need to set this to 24.6, right? So I'm going to go down to 24 if I can. Click on the battery. And can I make it to 24? I got close enough, 24.5. All right. So get as close as you can, and then go back and make sure you set up your resistors. So we only got to set up resistor 1, which is this one, and resistor 2, because we got to figure out what resistor 3 is. So resistor 1 is 255.2, everybody. That's from the problem that she just read. So we click on the resistor and we see if I can get there. Ooh, it stops at 120. All right. So we're going to set it to the max of 120. And then what about this one? Well, if the max is 120, we'll set the next one because that's 150 by a factor. So we'll set that to about, I want to say 100, maybe 90, 95 or something like that. So click on it and get it to about 95 ohms because these are limited. I want it to be exact, but this is fine enough. So 95. So we know have a factor difference. These 100, a factor of 100 or something like that. The last resistor is resistor 3. Now here is what I want you to see, what it looks like in textbooks, right? Resistors have these little wavy lines. Turn the values off so you can see it. But this is how it's represented in most of the industry, right? So if you look at a blueprint, you'll see this. If you're looking at a cartoon version to understand it, you'll see this. Also notice with the resistor levels, it's not really moving that fast. So if we were to connect, let's say this bulb that's been sitting here, I remember I told you I was gonna come back to this circuit, it wouldn't be that bright, right? Because you see how fast the electrons are moving. So what I want you to recreate is this circuit and then set up your resistors so you have the most brightest bulb if you can. So let's bring it down. You'll see the color bands change for the resistors. Notice when I change the resistance, the bulb gets a little brighter, right? See those little rays of light coming out the bulb? So you have to do the same. Make sure you can at least see your bulb, and you have different types of resistors, but just make sure, like I said, when I say different types, you have different colors of the resistor. Like this value is 23.0, this value right here is 16, and this value over here is 22.5. And you just want it to be bright enough. You're gonna go over here and take a snapshot, click turn the values back on, make sure they're there too. But before you take your snapshot, I want you to use these tools to get into this problem. So I want you to measure how much is coming off of the bulb. So one black lead goes to the exit of the electrons. The other one is the entry. Okay, can you see what I'm doing? I'm making sure it's connected on 2 points of the bulb. So the black goes to the bottom part of the bulb connection. The red goes to the top part. There's 2 connections for that bulb to start. Lastly, ammeter. You got to pay attention for this one because this is going to be a little difficult if you don't know what's happening. I want to see how much current is actually coming off of this second piece. So to do that, I'm going to cut this, and we're going to finish up by connecting it, because current meters or ammeters, they have to be connected with the circuit. So let's drag this over. Let's move this out the way so you see everything entirely. I'll take one more wire and we'll connect it to the end. Now you'll see how much current is across, and then this bulb, before the current got there, let's put that back. Let's put this one back. You'll get the actual voltage on the bulb. All right, so here's your snapshot picture. You need 2 minutes to get it all down because we have a lot of steps to power through for this problem. You want to make sure you get all of them. When you're ready, we're going to take the snapshot and put it into our Google Doc. But this is essentially what's happening in your problem. Okay, about a minute left to have this set up. We're about to take a picture of it and put it into our document. Okay, so we're going to take a snapshot, right? And you do screenshot here. It'll download a picture of what we worked on. So click on screenshot. Did it do it? There it goes. It's downloading. Done. Now I can come over to my Google Doc here and put my screenshot into the document. Yeah, I click on Insert Image and come over to Upload from Computer. It'll pop up a menu or directory, and I just find the picture I downloaded. Hit Open, and et voila. Also want to make sure I click on the picture and select wrap text so you can move it around easily. You might have to do a little editing of your document because see right now the picture's in the middle of the word. So I just click on the picture and move it around with my directional keys or arrow keys on my keyboard. If you did wrap text. Okay. So now for the problem. And it's 12:46, so we got to work a little fast on this because there's a lot of steps to this. All right, so what do we start with? Well, if we go back to the problem, we understand that we're given the potential, which is the battery, and a few other values. But an equation we need to know is how do we calculate equivalent resistance? Because we got to find R3. And that's where REQ comes into play to help us out. So let's begin this. It's a nice little journey. So first things first, you got to know that equivalent resistance for resistors in series, this is a series circuit, it's a loop, right? Is measured by looking at the equivalent resistance, which is usually REQ, being equal to resistance 1 plus resistance 2. Just do this. So I have to retype and retype and retype. Resistance 2 plus, of course, resistance 3, but this can go on forever and ever if you have enough resistors. So in our case, I'm putting resistor 1, resistor 2, and resistor 3, and plus ... meaning you could use this over and over as more resistors in the circuit. All right, so let's center all this because these are your notes. All right, food for thought. Now, how do you write this mathematically? So it's going to be R EQ, not tequila, I said R, what the heck? EQ, there we go, is equal to R1 plus R2 plus R3, right? So now we got to subscript these because these are mathematical equations. So it'll be format text. I'm going to drop that down using subscript. Do the same thing here. And you can use shortcuts if you want. I think subscript is control plus the comma. So for you don't want to feel like going up to format, if you know that shortcut, you could use that. So it's control and comma. And then I think I like that. That'd be cool. And control and comma. All right, so we have that set up so we can use it. And remember, this can also make this known. This can also mean you got more resistors if that's the case. But we only have 3, so we're going to just use this setup initially. All right, the unit for all of these is ohms. So you have the first resistor is going to be ohms, right? That's REQ, equivalent resistance, equals ohms. So they're all ohms basically. Right. So you know what resistors are measured in. That gives you an idea of your first set of notes. It brings down so it's all together on one page. See that? Now we have to move on to, and I almost forgot, don't forget to put your second question in there. Gabriel helped us out with that. It's 10 points, thank you. So the second question has to go in there because you got to go back and do that question, right? So don't forget that's there. Put that in your document as well. Now, known and unknown values. So let's look at it. Known values. Unknown values. And what do we have to work with? Well, we know that the voltage, which is pretty much an epsilon. This is the Greek letter for potential voltage. So you go to Insert, Special Characters, and you're going to go make sure we select Math, right? What is the symbol? Uh-oh, something's wrong. Hold on. I said Math. There we go. Let it load its library. Click on epsilon. So EP. And is that it? There it is, epsilon. So EPSI, it'll give you this signal for epsilon. All right, this is not the one I want. That's a different math operation. Is equal to, and that means our voltage, the potential difference. So that was our battery, right? And our battery was, what did they say? 24.6 volts. So 24.6 volts. We're given what else? Our current I. That's equal to what? Remember, current is used for Ohm's law. So if you remember that, I'll type it in again for you. But that is our current they gave us, and that was the amps in the problem. So we go back up, that is 0.0327. Okay, so 0.0327, and that's amps. We know what resistor 1 was, right? So resistor 1, control that. That's called subscript. And equal to, what do we have? What was our first resistor called? It was, let's see, resistor 1. R1 was 255.2. This is ohms, right? R2 was what? R2 is equal to, let's see here, what was that? It was like 157.8. 7.8 ohms. And now we have to still define what we're looking for. So in part A, you're aware, the problem is asking for, let's come here. I can just put R3, so 3. You gotta make sure you do subscripts and stuff like I'm doing, everybody. Some number we're gonna calculate in terms of ohms. All right, I'm gonna move it down one because the R3 needs something else. It's called REQ. They don't tell you that in the problem though. They don't say go find REQ. You kind of just know you gotta find it, and that's what we kind of defined earlier. All right, so we got this, we got that. Now, what is our part B value, which I hope we can get to? Part B. It's gonna be an exercise of Ohm's law for you guys. It says you gotta find 3 different unknowns here because it's like the potential differences for V1, V2. Someone's coming in the room. We see what this is. They don't show yet. But V1 for voltage 1, right?
Mr. Tyler, is this the character we're supposed to use? I put
Is
it
it
in
what? Is it
the
what?
character.
I can't hear you, sir. What'd you say?
The character?
The character?
Yeah.
Right. How to get the character is what you're asking?
Yeah, I put it in the chat. Is that the one we're supposed to use?
Yes.
All right. Thank you.
No problem. So we know we got to find voltage 1, 2, and 3 because it's 3 battery, 3 resistors, so there's 3 voltage values. The voltage across each one is going to be different. So that's volts. And I'm just going to take this and redo it because you need 2 more. Some of these steps you guys are going to have to calculate on your own so you can get the hang of it. Because I don't want to do all the work and you just don't have no practice time. So we're going to find all 3 of these, hopefully before we leave class. Okay, put that there. That's not what I wanted you to do. Come here. There we go. And that's going to be V3. Okay, so far so good. Now we are ready to calculate everything. Okay, so you know what you need for each section, part A and part B, right? Potential differences of the voltage values. Now, you might have forgotten something. Remember we talked yesterday about Ohm's law, right? And Ohm's law was basically voltage is equivalent to the current multiplied by the resistance. Voltage is always in volts. Current is going to be in terms of amps. And resistance is, again, ohms, right? This is a rebuild, a more advanced concept of what we already studied. Let's try to knock this problem out so we can finish out a little bit early. I think we can get it done. So if you're having trouble, I'm going to put this in the chat, all these notes, and you're going to have to edit it while I work on the rest of the notes. I'll scroll back up, but again, I can't let you go early if we don't get too much done. So let me see how much I can fit in the chat first. Okay. And it's going to look kind of murky. Okay, yeah, I think I got it all in there. Yeah, but you got to edit the same way mine is. Okay. So let's begin with the strategy. How do we begin solving this stuff? So strategy. Oh, there's one other value you need here too for part A. And let's say, and you need REQ. Right? Let's not forget about that part, which we're going to figure out in one moment. Is equal some number in ohms as well. Let's put ohms. All right, so strategy, all right? Basically, use Ohm's law to solve for REQ. Okay? So it goes like that. Via, or by way of, or I should say utilizing, use the mess out of via, algebra. Okay? So let's begin. Let's begin. We're typing in Melody arrived. That's who it was. I just looked over and said, who is that? Okay. Welcome to class, Mel. Hope you can catch up. We're putting some of it in the chat. All right, so let's go through the problem, right? We know that Ohm's law, and this is another version of Ohm's law, by the way. It is, we didn't write the equation for it yet. So it's going to be V equals I times R. Another way to write that is also V is equal to, or not V, epsilon. You can know what I'm doing here. That's another way of saying potential difference. We can say epsilon, brother, all right, is equal to your current multiplied by your REQ. All right, so you know what that is. All right, so now that we have that, we're going to use this equation, which is similar to the above ones, to solve for our REQ. So put that into play. And how am I looking on time? Great. So I got 10 more minutes with you guys. I think I can finish it off this way. So, because I want to give you a little bit of time early, 1:20. You might leave 5 minutes early, everybody. It depends if everybody's keeping up and they can share out something at the end. Okay, so strategy. We're going to solve for REQ using algebra. You just do what you know about algebra. Get REQ by itself. So if I is multiplied by REQ, you got to divide by I, right? Let's go ahead and take care of that. Put parentheses around this because it's a product, but I want to divide out what I don't want next to my REQ, and that's I. These are the changes to the equation. But in algebra, it states what you do to one side, you got to do to the other, right? So let's do that. So now we have this new situation. Okay. So we clean the equation up now. And we end up canceling out the i's, right? Cancel that one out too there. And this I and all this multiplication. It's just REQ that's left right there by itself. Okay, so now I'm ready to clean the equation up. Here, I don't have nothing here, and this is gone as well. Cool. Now that we have what we need, let me move it over. Write it the correct way, by the way. Okay. So that's cool. You can now, before we put numbers in, figure out what REQ is, because we have a way of calculating it. So let's just keep that in mind. So let's put these values in. And what is our epsilon, or our voltage value? It's 24.6. I'm just going from our known values above, 24.6, right? And that's volts. And the current is, if I remember, let's come up here, 0.03. Let's leave that right there so I can see it, 0.0327, and it's amps. So far, so good. What happens is when you divide volts by current, you get ohms. So we end up canceling out our amps and canceling out the volts, because when they divide out, they create automatically ohms. Okay, so over here is ohms. Okay, so let's rewrite our equation now. And that's going to look like this, right, where we remove amps and we remove volts. And now we just got to calculate it. So that's going to come to, let's see what Google says. Take this part only. Like Google, how much is that going to be, right? So come here, make sure you press equal sign when you type in the calculation. And if I hit enter, I get 752.29. So come here. That's going to be, like I said, 752.29 ohms. Okay, so you're not done, because that's just one part we needed. Now we got to go back and find R3. Okay, so we're halfway done with everything, y'all. So hang in there. Next, we want to look at, and let me put this in the chat for you guys so you can get caught up, but you got to edit the same way. So just start getting the notes in there, and towards the end, we're going to make sure you edited everything correctly. So here you go. You might not be able to see what I'm doing. That's why I'm being fair, but bear in mind it doesn't cross out or edit correctly. So that's what I've done so far. Next, we got to figure out what R3 is, right? That was in our known unknowns that we were looking for. So let's go through it. We have the situation where we want to find REQ, and REQ is, if we look here, is basically this situation that we talked about a long time ago. So I'm gonna copy that from there and put that here, right? And the strategy with this one is going to be now solve for R3, right? Using algebra via equivalent resistance. Equation. Okay, so let's do that. All right, how do I get R3 by itself? Well, I got to do the opposite of everything around it to get it to the other side of the equation. So that's real simple. Let's just look at that. It'll be these two, right? R1 and R2. I want to do the opposite of those. I'm going to take these for a second. And I'm going to say minus, right? And then this is going to be minus 2. So those are the changes. Make it known that's a change. Well, what I do one side, I got to do the other, right? Just to annihilate the R1 and R2 on that side of the equation. So now it just becomes simply that over there. And we got to clean this up. So what is it going to be? Well, let's first get rid of all of this jazz here because that's going to cross out with the positive version. Cross that out. And all of this is gone too now. So all we gotta do is clean up the equation and then figure out what R3 is. So this is gone, right? And this is gone. We're gonna put this on the other side because that's what it's gonna be equal to. So now we're ready to actually put the equation into play. Do some more algebra. We did the addition subtraction version. Who is beating up their computer? Who is that?
That was me.
Oh, okay. I'm like, what did it do to you? All right, so let's finish this off, you guys. So we're gonna go here and we're gonna take the resistance values that we know. So that's 255.2, right? Ohms. Come here, and that'll be our R1, right? So that was R1 is gonna be 255.2 ohms. You should know what REQ is. We just calculated that. I'm just getting the stuff we already had. So R2 was 157.8. ohms. Close that parentheses. What was REQ? Go back upstairs in your notes. We just did that one. That was 752.29 ohms. Okay, so I'm going to take that here. And now we have, I think, everything we need to finish off that first part A, right? So I'm going to do part B, but I'm only going to do 2 versions of part B for you because it's real quick and easy if you understand it. And then we don't forget to put your simulation into this document, everybody else who didn't do that. So what is the final answer, right? Well, we're just going to use our trusty Google calculator to determine that. Let me come over here, come down the line, and all these ohms are going to become 1. So we end up with a new calculation of this, right? So I'm going to cross out this. All these is going to become 1 ohm. They're like terms if you look at it that way. Okay. And what pops out over here is ohms by itself. But when you redo this, you have a new calculation of what? Well, let's get rid of it. Let's clean everything up. So that's gone. That's gone. And pretty much all that jazz is gone too. The 52.29. There we go. So that's not separated anymore. So it's all 1 parentheses. Excuse me? Said that. Okay, I guess nobody. All right, so let's calculate out what the final answer would be to part A. And then I'm going to give you steps on how to do part B. And we're going to call it close in about a couple more minutes. We're going to leave about 5 minutes early. But after I do this next step, I want you to share out to show how much you got to see if you should leave early or not. So let's calculate this. This is going to go in Google Calculator or any calculator you want to use. Take that and say, hey, Google, what is this going to be? I'm crunched for time. I need to know. Make sure you put equal sign in there, and once you hit enter, it becomes to 369.29. So that answer reduces down to equals 369.29 ohms. That is your R3. Okay, now that's just one portion. Let me help you with part B. And remember, the problems are similar. Okay, you just have to take your time like I did and calculate it out correctly. All right, so what do you need for part B? Well, you need to understand Ohm's law is used here. So we need strategy use Ohm's law to calculate the potential differences of each resistor. That's 3 resistors, remember? So I'm going to do 2 of them, or try to in a moment. So remember, Ohm's law is here, right? So we're going to use this original version, but we have 3 resistors to account for. So the first one, remember, is V1, V2, V3, and part 3. So the first one, let's put this here, right? We're going to name that our first calculation. Yeah, I know, I'm not leaving yet, though. So we name that first calculation. It's over. And this is Ohm's law when I'm talking about use it. So the first one is going to be, let's say it's going to be R1 and V1. Change those up. Right? Next one is going to be what? Who can guess? It's real simple if you understand it. The next voltage drop is going to be R2 and V2. Okay. There's one more, and that's going to be, you guessed it, R3 and V3. So we're so far so good. We're going to find the voltage drops across each resistor. Now we put the values in because it's set up just so you can calculate it. So I'm going to do 2 with you, and then we're going to get ready for share outs. Yeah, she said this is the longest problem I ever did. Oh, I didn't get y'all the rest of the notes, huh? Okay. Yeah, you want to get paid, what is it, $100,000 to $150,000 a year being an electrician or electrical engineer? This is some stuff for you. They will look at your resume different. Okay, so those are the other notes that I just did to find R3. This is almost done. I know I sound like the pastor or preacher, but I'm telling the truth. All right, so how do we calculate this? Use the values we found above, right? So what was, let's space this out some. What was I, or the current, a long time ago? Well, I don't have to go too far for it. If I remember, it's 0.3, this part here. Come down, and that's my current, right? What about R1? We know what that is, right? Come back up here. R1 was, I think it's his first value. It was 252.2, right? It's also in your known values. So I'm just going to take this and come downstairs, and that's what goes inside of that one. Okay. Remember what happens at the end of that calculation, you get at the end of it volts. So some things cancel. So basically this crosses out, and you get volts at the end. It's amps by multiplied by ohms gives you volts. So let's go ahead and fix that. And then fix this. And that'll be volts at the end. Let's clean it up. And I want you to calculate the final answer to that one. Please finish it up, guys. I did the steps to get you started, but you got to do the final calculation, though. Okay, so what does the other one look like? Well, very similar. You got one more to calculate, right? And then come down and space that out. You know you got to do one more after that. Ooh, I literally finished close to the time I wanted to. So now the values that go in here, you should know them by heart now. This is not done, by the way, so let me put a note here so you guys know it's still a question mark you got to figure out. All right, so this is all gone. It's going to be something you got to put in Google Calculate to figure out. Not done. Don't stop there. You got to do the same thing here. What was the current? Current was pretty much this. It has not changed. Right, this right here, right? I'm down here, and this is my current. And the resistance was what? That was the 157.8, right? .8 ohms. And don't forget, you got to cross some things out. It's 11:15. You got to do the same thing for V3 and finish it off. And I'll put these last bit of notes in the chat. But who is ready to share out their screen so they can leave a little bit early? I'm going to put the final notes on here for you guys.
Mr. Tyler, can you scroll up from the like a little bit to the beginning so I can screenshot?
Sure. One moment.
Yeah, I need to screenshot all that.
What you finna put the stuff that you just did in the chat, right?
I can.
Yeah, do that for me.
Yeah, I can do that, but you got to do the calculations for me. A lot of y'all been turning the work in with the calculations not done, so it's been lowering your score. I got steps in here to finish. So you got to do the same thing I just did for V3 and finish it off. But let me scroll up. You got to tell me where though, because some of this stuff is already put in the chat. Nobody's saying nothing.
The last begin at the end, the one after this, the one that you just put in the chat, the one after that.
So the one after that, that's part B, right?
Yeah, I think.
Yeah, it's all part B. So I'm gonna put this much in part B in the chat. And you guys got till 8 to finish it, so make sure you finish all parts.
Can you go all the way up?
Yeah, that is just plain wrong. That's like those women who wear those Wonder Bras. You get.
Okay, I'm all the way up now. You gotta tell me where though.
All right, go down. Right there. Hold on, wait. Up a little bit.
She is at home being
Oh.
a good little girl. I'm a supervisor. Yeah.
All right, go down.
Guess you forget how you were at 14.
Down. Go down.
You better not be in that liquor cabinet.
Down.
Oh, no. That is just playing.
Down.
All right, I'll tell you later.
Oh, man.
Down.
There she is again. Like a Terminator, she keep coming back.
Down.
Excuse me.
That's
Can
it.
you go up a little more? Can you go up a little more?
All right, I'm
Shut
done.
up.
Okay.
Shut up, bro.
Oh, whoa. What's going on? Okay, she's having trouble, I guess. All right, so don't forget you got these last two parts, guys. It's 118. Does anybody want me to show you what the last steps are, or you guys got it? Don't forget to turn this in by 8 p.m. tonight. So you guys think you can handle this last voltage drop? It's the same calculations, but you got to make sure you put all the steps for this last part. Last steps.
Yeah, can you do the last steps, please?
Sure. I'll take a little time with that. So the last steps are similar, right? So if I come here, we're going to plug in the values, right? So that's again the 0.03, the amps right here that goes into I. It doesn't change from each voltage drop. And then this is resistor 3. We figured that out a moment ago here. So we'll take this. And that goes here. So put that in parentheses. And turn that off. So now what you end up with is you got to cancel things out again, right? And this crosses out. And this crosses out. And you have volts on the outside of that, right? It's like above the other 2 times we did that. So the final answer, once we clean it up, it's going to look similar to the last few steps we did for the other voltages. This is gone, and this is gone. You still got to calculate the final answer, everybody. So you end up with some number that you got to figure out. It's going to go right here. Okay, so class is officially over. Those are all the things you need. You got to calculate. I shouldn't see the report with just question mark. You should have an answer. As much as I didn't did, you should find those 2 answers at the end. Don't forget about the homework problem. Okay, it's similar to what we just did. It's very similar, but you got to do all the steps to get 100%. Now I did half of it for you. You got to go back and practice it using that problem, that homework problem. Turn in both, because I see a lot of people are turning in half. It doesn't help your score. It's like 50%. So take your time, not going anywhere, to finish copying your notes. Okay. Well, the video will be available too later, Lisa. I'll see you around.
Have a good day, everybody.
You too. It's all good.
Thank you.
Got a question, Gabriel?
No.
So if you have all the notes you need, you're free to leave. It's 1:21. I know your next class, I think, starts at 1:30. You got until 8 p.m. to finish all this, so just make sure it's typed up and submitted to Edsby. Hey, Miss Richardson. Still trying to take down some notes.
Y'all had ended up leaving, but I had forgot that I didn't get the bottom. I thought I had it.
Okay.
Wait, I do got it. I'm tweaking.
Mr. Tyler, could you scroll up to right before part B, please?
Yes. You talking about right here?
Yeah, thank you.
All right.
All right. Do we have to show your screens or no?
No, we're out of time. You can go.
All right. Thank you, Mr. Tyler. Have a great day.
Yep, just turn in by 8. You too.